All right, this is the data science interview question that I'm going to be going through today. It's from Amazon, and I found it on Glassdoor. I'm not going to try and search for it right now, but this is the question. If given an integer n and an array of numbers, give out the histogram divided into n bins. I think this should be like make a histogram divided into n bins. But so first, I'm gonna create some variables. I'm gonna do in. I'm gonna have 4 different bins, and I'm gonna use NumPy to make some random variables. NumPy as np, and then array is gonna be np.array, np.random.normal, and I want 1,000 values. So I want to divide this into 4 bins. What I'm going to be doing to do this is np linspace. So if I do np linspace of array.min and array.max, and I want 4 numbers. So if I do this, I just kind of want to think about this out loud. So first I have my minimum value. I have my maximum value. So my first bin here is going to be -3 to -1. That's bin 1. Here is bin 2, and here is bin 3. So I actually want five bins. So this would be n plus 1. So then between these 2 numbers will be bin 1. Between these 2 numbers is bin 2. Between these 2 numbers is bin 3. Between these 2 numbers is bin 4. So now I have the values that I want to be doing the putting in the bins. So I'm going to now write a for loop that will put the values in between these bins. So to do this, what I'm going to do is I'm going to iterate through this variable right here. So for I in linspace, and need to copy and paste that. And what I'm going to be doing is doing a filter on the array. So if I want this first bin right here, what I'm going to do is array is greater than or equal to this -3.78 number, and array is less than this -2.1 number. So this gives me all the values that are greater than or equal to -3.78, but also less than 2.1. So I'm going to be using this notation to place the numbers in the appropriate bin. And when I do this, think about this for a second. I want to save this to a dictionary, so I'm going to call it bindict. And if when I do this, let me just don't print high. So the first time through, so I think what I'm going to be doing, and I'm going to explain this, is the first time I go through this, I'm just going to save the previous number, and then that way each time through, I'll be able to have the previous number and then the current number, and I can do my filter on that. So if not previous, continue. And I'm going to add stuff in there. I just want to print out what I'm talking about. So print prev. Or actually, I will put that in there. Print previous and I. Previous equals I. Oh, I want if prev. So here it is. So So the first time through, these are for my 4 bins. So I want numbers that are greater than or equal to this number and less than this number, greater than or equal to this number, less than this number, greater than or equal to this number, etc. So when I do this, I'm first going to make a variable where I do my filter. I'm going to call it vowels. And this is going to be array. Array is greater than or equal to previous. And array is less than I. So I got my values. Now I want to add this to my bin dictionary. And I'm going to add an enumerate, and I'm going to use that as the key in my dictionary, the counter variable. And I'm going to do counter plus 1, and it is going to equal, so the values. But the reason I'm making it a dictionary that the values are going to be, this part right here, is I want to make a bar graph with this. And for a bar graph, I want these values as well. So this is, I'm going to call this range. Range. And this is going to be prev and I. And if we take a look at what we have now, so here's bin 2, here's bin 3, lot in bin 3, lot in bin 4. Something went wrong here. Oh, I don't want a counter plus 1. I just want counter. So bin 1, very few values. Bin 2, a lot of values. Bin 3, a lot of values. Bin 4, a few values. And that makes sense because I'm sampling data from a normal distribution. It should be bell-shaped. And this is why I wanted to do a normal distribution, was because I could use that to verify. Import, let's do matplotlib.pyplot as plt. So now I want to make an x and a y variable. So I can loop through my bins. So for bin in bin dict.keys. And if we take a look at bin dict, let's just grab the first one. So I want this range here. So if I grab the range, and then I can do np.mean. So I can copy that over. And I want to replace this with bin number. So this is the average of the range, and that's where the bar x-axis is going to be on the bar graph. And then I just want to take a count of all the numbers. So this will be, I'm just going to copy this over. But instead of np.mean, I want to take the length of vowels. And let's see how this looks. And let's do a bar plot. And we see it is roughly a normal distribution. Reason it doesn't look that great is, again, because of the number of bins that I have. If we increase this to, let's do 10, run all this through, now it starts looking a little bit more normal. I want to make a function now, and make list, and then it's going to take in 2 values, array and n, and run this. And I'm also going to make the plot as well. Plot.bar plt.ship and make hist. And we have our array, which is array. We have 10. And it does not display. Oh, I forgot the bar plot. Just did plot.show. So if we did 100, looks a little bit more normal. We see we have a value of -4, which is an outlier. But if let's say we make this again and we did 10,000. If we run this again, we get a pretty nice normal distribution. If we do this with a uniform distribution, we should get a uniform distribution. So roughly a uniform distribution. So this is my solution, and let me know if you have any questions. Thank you.